Awesome. Great. Thank you. All right. So we can go ahead and get started now, except for that. Is my screen sharing, still sharing? Can you still see my screen?
Yeah.
Okay,
yeah.
Great. I see Aldo's thumbs up. All right, fantastic. Okay.
Okay.
So I'm going to talk today about version control with Git and GitHub. You've already got this link in the chat if you would rather follow along on the slides in a PDF instead of in Zoom. Starting out just a little bit about what version control is and why you should use it. It's a way to track changes to your code and know when something changed in the code and who made that change if you're collaborating with the team. So that's really useful if you realize you've introduced an error at some point to go back and know when that error was introduced and what has maybe been affected by that, or if there's a piece of code you don't understand, to see who actually wrote those lines of code, to go talk to them and ask them to document their code better. Or if you, for some reason, need to revert to an old version of your code, like if you've developed some code, you've published a paper based on it, you've kept developing it, and then somebody wants to reproduce the results from your paper, you want to be able to get back to the exact code you were using in that paper, similar to archiving the specific versions of your code. Or if you've made some changes that you realize actually weren't a good idea and you want to get rid of them, that's another good reason to use version control. And Git is the most popular version control system out there, and it's free. So that's the one I'll be talking about today. So just wanted to make sure it's clear the difference between Git and GitHub. So Git's software that runs on your computer, and you use it to manage the code that's local on your computer, on your hard drive. And that program runs from the command line on your computer, so you're interacting with it by typing commands. GitHub is a website for hosting software that you manage with Git, and it allows collaboration with others on those Git-based projects. And GitHub, you can store your code either publicly, so anybody can see it, view it, and then do what's called forking it, where they create their own copy and they can modify their copy, and then you can pull those changes back in if you want. Or it can be private, just you and your collaborators. And in order to use GitHub, you have to use Git, but you can use Git without using GitHub. The software doesn't require the website. So I'm going to start today by talking about the software, and hopefully we have time to actually get into talking a little bit about how to use the website as well, just depending on how long the I want to make sure that everybody's kind of actually using the software during this workshop instead of just seeing me talk about it, so you get a little more experience with it. So a few quick concepts before we get into actually doing a live, hands-on interactive demo about some of the concepts in Git. So a repository in Git is your storage for your code for a single project. So if you had one project that could have a handful of code files and things like that, you would have one repository for that, and that would contain all the history of how those files have changed over the course of your project. A commit is one set of changes to the code. So if you make some changes to the code, then when you feel like you're in a good place with those changes, you can commit those changes. And that creates kind of like a checkpoint of exactly what the code looked like at that time. And your repository can contain thousands and thousands of commits of different versions of your code as you continue to work on it. A branch is a specific version of the code where you're trying something. So if you've got your master, kind of like your main code, and you're like, oh, I want to try adding this feature or try running this model in this way, you can make a branch off that. You can make those changes. If you like them, you can merge them back into your main code. If you don't like them, you can not merge them back in, but then you have them there as kind of like a path you went down that you didn't end up saving, but it's there if you ever want to go back to it. And that allows you to, if you're developing some major change to how your code works, you can work on it in a branch and then still go back to your main code if you need to keep using your main code while you're working on that branch. You can tag a specific version of your code. So whenever I publish a paper, I always tag the code I used for that publication. So then if I keep working on that code for other projects in the future and somebody says, well, how exactly did this work in this publication? I can go and look at exactly the code that was in use at that time. And then the working tree is the copy of your code that's on your local computer, which you may have modified since the last commit. So the repository is only containing the changes you've committed. When you modify the code, that's just the files on your computer, and that can be ahead of where your repository is until you commit those changes. Any questions there? I want to make sure this is interactive. Hearing none.
No.
So just before we really get into this this demo, I want to talk about what you should put in version control. So definitely you should put your code in version control, and any text-based documentation you have. So things like tech, markdown, things like that you've written about your code. Maybe if you can put like, your Word and your Excel and your documents like that are kind of smaller that are related to your project. I say maybe because a lot of the tools in Git about like looking at like how has a file changed between different versions and stuff like that aren't going to work with those binary documents. So you can still store different versions of them, but you won't be able to say, what lines of the file changed in different versions. And then you shouldn't keep your large files that are larger than a few megabytes in Git, because those will start to really slow things down because it's actually keeping track of the content of all those files. And then your data files, I generally don't like to keep those in Git for a couple reasons. First of all, they shouldn't be changing a lot, and you probably want to keep them kind of separate from the code you use to process them. The other reason for me, and I know this may apply in some of your research or not, is that I'm a social scientist, so a lot of times the data I have, I can't share publicly because it's got personally identifiable information or something like that in it. But I still want to be able to share my code on GitHub, so I don't want that data to be checked into my repository when I go to share my code. So little bit about collaboration on projects that use Git. So you don't want to share your Git repository with your code in it with others via things like Dropbox, because that repository is tracking all the changes you have made. And if you and somebody else make changes at the same time, you could corrupt that. So services like GitHub are purpose-built to allow collaboration with Git, where you'll make all your changes on your computer and then push them up to GitHub where other people can see them. All right. So I'm done with talking about just you watching me talk. I want to get into a demo. So if everybody can download and unzip this file, which just has a couple of, it has a code file and a README file in it, but just so we all have like the same code to work with as we're doing this demo. So if everybody could do that, and then if you open the participants window, you can there's like a yes and no button. If you click yes, I'll see that next to your name, and then I'll know once everybody has that downloaded and unzipped. All right, great. So now that everybody's got that, so we're gonna go to, just unzip it myself. We wanna open a terminal window where that is. So this is how you open terminal window on various different operating systems. I'm guessing most of you already know that, but I wasn't sure who would show up. So I'm gonna go ahead and get over to my terminal here. Does that work for everybody? Everybody's in that, got a terminal open in that location? All right, so once you're there, there's a couple things you want to do to set up Git, and you only have to do this the first time. You don't have to do this for every repository you create. Just the first time you install Git on a new computer, you want to do this. So you want to run these two commands that set what your name is and what your email address is, so that you have, so that when you commit things, they're attached to your name and email, so you know who committed them. If you're planning on pushing your commits, your code to a public repository on GitHub, whatever email address you put in here will be public. If that's a concern for you, you should skip setting your email for now, and then later you can, if you've downloaded the slides, there's a link here about how to keep your email private on GitHub. Basically, it involves, once you've created a GitHub account, you get a special email that's something at noreply.github.com that you can use. And the reason you want to put an email address in there is that's how your commits that you make on your own computer get linked to your GitHub account when you do, if you do push your commits up to GitHub. So I'm just going to go ahead and do those two things on my own machine here. All right, anybody have any concerns there, or can we move on? Oops. So here's how to create your first commits, set up your Git repository, create a new Git repository. And this is something you're going to want to do in every time you create a new project that you want to store in Git, you want to do this. So in the directory where you're storing, whatever you want to check into version control, you're first going to do a git init. And what that does is that's setting up an empty Git repository. That's just initializing everything. And you can actually see, if you look at that folder, that there's now this .git folder, which is where your whole repository is going to be stored, and all your version history will be stored in that folder. And then, so now we've got just an empty repository. And the first thing you want to do with your repository is you want to commit some files to it. So in this case, we've got, I've got a README and a demo R file here. And I would recommend making your first commit very early, because there's no, like as soon as you've got the project set up and you've created a few files in there, I would commit them, because you can just keep committing as you change them, and that way you can keep a record of all your modifications. So I'm just going to do git add readme.txt and demo.r. So what git add does is it stages those files up to be committed. It doesn't actually commit them yet. And the nice thing about git add is that you can run it more than once. So instead of running this command where I added them both at once, I could have done git add readme.txt and git add demo.r as separate commands, and it would stage all those things to be committed. And that can be useful when you've got a lot of stuff to commit. And then to actually create the commit, I'll do git commit -m, which is the commit message. And then I'll type in what I want to say about this commit. And you want to be as descriptive as possible here, because then if you're looking for a commit in the future and you want to go back and say, okay, where did I change this? You'll be looking at those messages. So right here, I'm just going to say that this is my initial commit. And then it prints all this stuff about what the commit actually did. So in this commit, it created 2 files that weren't in the repository before. And this
Aldo,
is
did you get your, oh, sorry, Matt, I just noticed Aldo asked a question about it working on Windows. Did that work for you, Aldo?
So Aldo, do you not have the, when you right click in the folder, do you not have that, the git bash here, or do you, or is it something else?
Say that again.
When you right click in that folder on Windows, do you have like a git bash here option?
I don't think so.
So did you install Git using the like just by downloading it from the website that was in the original email about the workshop, or was that, did you have Git already installed from somewhere else?
That might be the problem. I didn't at all.
Sorry, you broke up there a second. You had it already installed from somewhere else?
No, I haven't installed it all. Sorry. My bad.
Oh, okay. Well, that, yeah, that's probably the problem. So let me just paste the, let me find that link from my original email and just paste that in the chat here. Let's see. I think it's right.
I'm downloading the installer already.
Okay, great. Hopefully, hopefully that won't be too difficult for you to catch up. Yeah. Anyway, so now we've created that, and then when you do that commit, what it prints out here is it shows that your commit has changed 2 files. So in this case, I created 2 files, but it tells you how many files were changed in that commit. And then this over here where it says 6 insertions, that's how many lines were changed. So it would say like 6 insertions. If I had taken anything out or changed anything, it would also have deletions. Because everything in Git is based on how many lines of code that were changed. Anybody else have any questions or concerns at that point? All right.
Nope, I'm good.
Great. So now, in order to demonstrate how version control works, we need to make some changes to these files. So I don't care what changes you make. You can modify them, create new files. That's all up to you. I'm going to just make some quick changes here myself so that I can demonstrate how that works. Just go ahead and also create a new file here. All right. So are we good with, have folks made changes to the files? Hopefully that's something everybody already knows how to do. So then when you want to commit your changes to your files, the first thing you want to do is to run git status. And that prints out a whole bunch of information, which you can see in the slide, but also down here. And so what it's telling us here in the slide here is it's saying, okay, I've modified readme.txt. So that's pretty straightforward. In this example that I did for the slide, I also deleted a file just so you can see how it reacts when you do that. And then down here in this section where it says untracked files, those are files that have never been committed to Git before. So README was previously committed to Git, and now it's now I've made some changes to it versus relative to what was previously committed. The untracked files are completely new files that Git doesn't know about yet. So let's see, I'm just gonna go ahead and delete demo.r just so what I'm doing here matches the slides. So that's what that slide's telling you. And then when I want to commit these things, I'm going to run git add for any file that's either new that Git doesn't know about, so in this case demo2.r, or any file that I modified to add those changes into Git. So I'll do git add those two files. And then if you've deleted a file, you can do git rm and the file name. And now that I've added all those things and I've got them all staged up, if I want, I can run git status again, and it will show you what it's going to do in the next commit. So it's showing now that it's going to make modifications to README. It's going to delete demo, and it's going to create a new file, demo2, in the repository. Right now, they're only in my working tree on my computer. They haven't been committed. And then I can just do git commit -m, and let's see, I'm going to say recommend more descriptive commit messages than this. And then we get kind of that same thing we saw before where it says, okay, I changed 3 files. I added 4 lines of code and deleted 5 lines of code. All right, I'll give folks a minute to do some of that locally, just so you kind of get the hang of how that works.
Matt, can I ask a question?
Yeah, of course.
So how does it handle if you like rename a file? Does it just come up as modified, or would it then be like recognize that as a new file?
So what will happen if you just move a file? Let me just, now that I've committed that, let me just move demo2.r, demo3.r, and then if I do git status, it will show that it'll show a deleted file and a new file. But then if I do git add and git and remove demo2, and then if I do git status again, it'll figure out when you add the 2 sides of that move, it'll figure out that, oh, those are actually the same file. The other thing you can do to avoid that is when you move the file, so let me just commit that so that I'm back to a clean tree. let's say I wanted to rename that back to demo2. I can also do git mv demo3.r, demo2.r. And then what that'll do is it'll move the file, it'll actually move the file on your disk and rename it, but it will also add it to that. It'll also add it to the, like stage it up to be committed at the same time. And then it knows that it's been renamed. So then I can just git commit that. Does that make sense? Folks good with that? Any other questions or additional questions there? All right. Moving rapidly onwards. So something that comes up a lot, at least for me, is that I'll make a bunch of changes to a file and then be like, oh no, I didn't want to do that. Actually, let's go back to what I had previously committed. So let's say that let's go back and edit my file here. Let's suppose that I accidentally replaced my entire README with the text of the Wikipedia article on Michael Crow. And maybe that's not what I actually wanted to do, but I accidentally pasted that in there. And then saved it. So now, so maybe that's not what I want to do. Maybe I don't want the Wikipedia article on Michael Crow in my repository. And if I do git status, it's going to show that I've modified readme.txt. So what I can do is I can do git restore readme.txt. And what that's going to do is it's going to pull the version of readme that I had previously committed out and put it back in my working directory, my working tree. So now you can see that there's nothing to commit, no modifications. And if we go back here, my readme back, don't have Wikipedia article of Michael Crow. Now, the important thing to remember with that is that there's no undo. So you should only do that when you're sure you want to throw out the changes that you've made. Now, another thing you can do sometimes, maybe you've made changes across a bunch of files, and then you're like, you know, actually, like I had this great idea. I started working on it and realized actually it was a terrible idea. I want to just go back to what I had. So what you can do for that is, so let's say I'd made changes. Say I'd just actually completely trashed all my files somehow. I can do git stash, and then they've all come back. And the nice thing about git stash is it does have an undo. So when you do a git stash, what it does is it takes all the changes you've made to the file since the last commit and puts them into a stash. And then if at any point you do git stash pop, it'll reapply all those changes you made back to the files. So now they're all back to these weird things I had before. Oops. Does that make sense? Any questions on that? Give folks a moment to try that out before we move on. I'm doing some time here.
So, Matt, these are changes that we have made before the commit, right?
Right, that you haven't committed yet. Yeah, I'll talk in a few minutes about going back to previous versions of your code.
Cool.
But yeah, I find that I do this a lot more than I go back to previously committed versions, because I figure out that it doesn't work before I've committed.
Yeah, that makes sense.
All right. So now I'm going to talk quickly about branches. So suppose you have some great idea for your project, but you're not sure if it'll work. So what you want to do is you create a branch. So to create, and basically what a branch is it's a copy of all of the files that are in your repository, so you can edit them all, make commits, and then that makes it. And then if you decide you don't like what you've done, just go back to your master branch and not bring any of those changes with you, but they still all exist in Git, and you can get to them later if you want to. or you can merge them back in if you want to keep using those. And the beautiful thing about Git is that it does this without actually copying your entire repository. So even if you've got, you know, a really big repository, all it's doing is keeping track of the changes in that branch. So you can make branches without worrying about running out of disk space or anything. So I'm going to do git switch to switch to a new branch. -C was saying that I want to create that branch. So you would only do this the first time you want to switch to that branch. And I'm going to call this branch awesome idea. Then it'll tell you it's switched to a new branch, awesome idea. So now I can go in here and edit this. And then I can make some commits. And if you're using an older version of Git that wasn't more than about, I think like 6 months old, you won't have this git switch command. It used to be called git checkout, but they decided switch was a better name for it. So if you have an older version of Git, I would recommend upgrading your version of Git because they have made some security patches recently. But if it's telling you that you don't have a git switch command, that's why. So then I can, like I said, I can make those edits. Let's see what I have next here. So I can make those edits. I can change some files and commit them. So I've changed some files. So I can get rid of that file that's untracked, created a mistake. And then I can git commit. If you don't put in that -m with the commit message, it'll ask you for a commit message. So that's what it's doing here. So now I've committed those changes to the README, and we can see that that readme.txt has that I have an awesome idea now added to the end of it. And if I now git switch master, and I don't have the -c here because I'm not creating the master branch already exists. It's the default branch when you make a new Git repository. It'll take me back to the master branch. But before I do that, I want to always run git status before I switch branches and make sure it says nothing to commit, which means I haven't made any modifications beyond what's already been committed. And the reason for that is because when you switch branches, if you have uncommitted modifications, Git will try to save those uncommitted modifications by, like, it'll try to keep those when you switch branches. So any changes you had made on this branch that you haven't committed, when you switch back to master, Git will try to make those changes on master so that you still have those changes. And if the code has changed a lot between branches, that can get kind of messy. So I would recommend just making sure that everything's committed before you switch branches. So now I can git switch master, and it's taking me back to my master branch. And I can see now if I go back over here and look at my README, that that line I've added and committed isn't there anymore because I'm on a different branch now. And then if I've decided actually that awesome idea wasn't so awesome, that's fine. I'm back at master. I'm back where I was before. If I want to keep that awesome idea, I can do git merge and then the name of my branch, which was, I think, awesome idea. And now it's merged those changes in. So now it's brought all the commits from that branch have been brought back into the master branch. So, and this is the way a lot of kind of like bigger projects work, is that every time you're making a major change, you'll make a branch, make your changes, and then once you're happy with your changes, merge them back into master. And the other great thing about this is if you want to make some changes and it's going to take some time to get it working, you can work in little bits, commit them, even if they're not fully working yet, because you know you've always got that master branch to go back to that is working. So you don't have to wait until something's completely perfect to commit it. Any questions there? I can give folks a little bit of time to kind of play around with making branches and switching between them and making commits on branches and merging them back together. If you use Git long enough, eventually you're going to run into a merge conflict. I could give a whole workshop on how to deal with those, but I won't. And there's a link there on how to deal with that. So that's what happens. That a merge conflict happens if you've made changes in your master branch and another branch, and you try to merge them together, and Git says, well, I don't know how to, you know, there's conflicting changes that I need to put together. Any questions about that? Folks ready to move on? Folks need a little more time to play with branches. All right, seeing some thumbs up. All right. All right, move on from that. I'm going to talk about tagging a commit. So after you've done a bunch of work, you've published your paper, or tags are cheap. There's no reason not to use lots of them. Maybe even once you've submitted, when you submit your paper, you want to know exactly what code you were using when you submitted that. You can just run git tag and then some kind of a descriptive name. Can't have any spaces or anything in it. Before we do that, you always want to do git status and make sure that there's nothing, you don't have any changes that you've made that you haven't committed yet, because git tag will only tag the changes you've committed. So let's say I've just submitted this for publication. So I could do git tag submitted to whatever journal I submitted it to, or something like that. Just something so I'll know what I was talking about here. And then I just run that. And then if I run git tag with no arguments, it'll just list out all the tags I have. So then I know that now I've created that, and that those words now point to exactly how the code looked like at this point in time. And then in a minute, I'll show you how to get back to that in the future if you want to replicate something from there. So let me make another modification here and then go back to and we can go back to it. So let's say I made some changes to my code since I submitted. Now, let's say I want to go back. Somebody says, okay, I want to see how your code was, exactly how it was when you submitted, or we need to reproduce some results from the paper or something. So then I can just do git. Let me get the slides back up here. I can just do, first I'll check git status to make sure that there's nothing that I've changed that I haven't committed, because if there is, again, Git will try to preserve that when I go back to that tag, and that's not what you want. You want to exactly what was committed at that time. And then I can do git checkout, and then I called that tag submitted to IJGIS. And then it's going to tell you a bunch of stuff up here that's actually, pretty useful if once you actually start using Git. And we'll talk about that in a minute. So now we're back at that tag. And if we look at the code I have, you can see that it's actually what it was before I made that commit that I changed after I did that tag. And this doesn't change your master branch. Your master branch is still exactly the way it was before you ran that git checkout. That all still exists. You've just switched back to that tag, but you haven't thrown away everything after that. It's all still there, and you can get back to it. You can get back to it. I thought I had that in the slides. You can get back to that as usual by running git switch master. And now I'm back on my master branch. I can go over here and you can see that my changes that I made since submission and committed have come back. So you're not throwing anything away by going back to a tag. You're just moving where you can think of your working tree as kind of like a view into your repository that you're moving around. And then you can also go back to something that, whoops. You can also go back to something that you didn't tag. It's a lot easier to go back to something you did tag, but if you didn't tag it, you can still go back to it by, you can run a command git log, and git log is showing me, you can see this is all the commits that I've made to this repository. Let's say I wanted to get back to how the repository looked right here, where I edited some code and changed the README. So this long string of letters and numbers here is a reference to that commit. But you don't actually have to know all of that. All you have to know are the first 6-ish letters. Basically, Git will, if you give Git a reference that's the first 6 letters, as long as that's unique within your repository, it'll know what you're talking about, so you don't have to copy all of that. And if it's not unique, it'll tell you it's not unique. You need to add some more letters to it. But in this case, so I can do git checkout 068 CEE, which I'm pretty sure is unique in this little repository. And it's going to check that back out. And again, similar to when I had the tag, now if I look at the code, now I'm back to where I was when I made that commit. Now, both with the tags and with the, and then as usual, I can get back to master by running git switch master. I'm going to go back to my tag so I can show you what you want, what to do if you want to. So now if you want to edit and make more commits and make changes to the code based on one of these old versions of your code, you'll get to your old tagger commit with git checkout. Then you can run git switch -c and a name. So we're going to do, call it edits from submission. And what that's going to do is it's going to create a new branch. And that branch now points to the code as it was at that time in that tag or that, that commit. And the reason to do that is because before you checked out this tag or you checked out a commit, you can't change tags or commits. So if you commit there, if you commit after you've done that, those commits won't actually be attached to any branch. They'll just be kind of floating out there. So you want to create a branch. And now I can make as many commits as I want to this branch. And this is just kind of like changes to the code that are branching off that point in my code history. So you can work on this code, you can make changes. So make changes to your code. I can commit those. And then that's all on that branch. I can go back to my master branch if I want to get back to the main code I'm working on. And now that I've created that new branch, I can go back to that branch also by running git switch edits from submission and get back to where I was based on those, starting from that tag with some commits past it. So that's how you would, if you want to keep making edits based on a past version of the code, that's how you would do that. Now, if you do that, you probably don't want to merge that branch back into master, because what's going to happen when you try to merge that branch back into master is Git's not going to move your master back to where that branch was. When you merge a branch, it's going to try to take all the changes that have been made to that branch since it was branched off and apply those to master. So if you've made a bunch of changes to master and then you try to merge in a branch that's based on a tag way in the past, it's going to try to just add the changes that you made since you checked out that tag back into master. And that's probably going to turn into a mess. So I wouldn't really recommend that. I would recommend, keeping a separate branch if you have like an old version of the code that you need to support or work with for a particular project, because you can switch very easily between those branches as needed. Any questions there? Give folks a few minutes to play around with going back in time. Oh man, I was gonna put a picture of a TARDIS on this slide. I forgot to.
That would be cool.
Yeah. Anyway, any questions there? I'll give folks a minute or two.
I don't think I have any questions like directly with like doing this, but I guess just a question for you as someone who's used this more. Like oftentimes I'll use a data set for like very different projects, and it seems like you could use like multiple branches. But for me, like normally what I do is I have like the original data, and then like from there I have just folders of like, you know, modifications that I've done for each of those different projects. Like because they're so different, it doesn't really make sense.
So like,
or at least I haven't done it where like I'm really modifying from like a previous version. I just kind of like go back, and the end goal is like different. So I kind of just have like keep it completely separate. Do you do that, or do you use that still with branches?
I pretty much, if I've got separate projects where most of the code's going to be different, I'll create separate, completely separate repositories. The right way to do it then is to use some kind of like a software or package management system. So create like an R package or something like that to do that. The other thing that I've done in the past is, this is like some advanced Git stuff that you can look into more later, but you can have Git submodules. So you can have a repository that's embedded inside another repository, and that you can embed the same repository inside multiple repositories. So if you created some code that was kind of like common code that you wanted to like import in multiple projects, you could create a repository that's kind of like Maddie's utilities, and then make that a sub project of multiple other projects where you want to have access to that code. Honestly, what I usually do if it's a small amount of code is I just copy and paste it between projects. It's not like the best way, but
yeah,
short
yeah,
of
that's definitely
actually
what I've done.
Short of actually publishing a package, you know, to some kind of like R, you know, R or Python package index, that's usually what I end up doing. Yeah.
Thanks.
Any other questions, or can we move on to the next topic? All right, so sometimes you'll have, say you made a lot of changes over time, and you're like, actually, you know, this one model that we were running, this one file we had really actually worked a lot better, you know, sometime in the past. So let's say I've got my file here, here are my list of my commits. Let's say I actually, you know, don't like what reviewer 2 told me to do. So what I want is I want to get the README back before that. So what I can do is I can use the git restore command, which we saw before. And if you run the git restore command without any options, just with a file, it'll restore that file from the most recent commit. But it can actually, if you add this source option, -- source equals, then you can type in a particular, either a tag. So in this case, I'll use the tag. I want to go back to the way it was when I submitted. Or if you don't have a tag, you can use this commit hash, this long string of letters and numbers. And again, you don't need the whole thing. You can use the first 6 letters or something like that. And then the file name. And so what this is saying is I want to restore readme.txt to the way it was in that tag or that commit. And now if we look back at my README, I'd no longer have the line I added down here about the bottom, about the changes I made in response to reviewer 2. Now, the git restore command, that doesn't commit it or change your repository. That only changes your local working tree. So if I do the git status, it's showing me that now I've modified readme.txt. So now I can commit that or add it and say, okay, add my commit message, and now I've restored an old version of that single file from my repository. Again, if you git restore is also a command that was added recently. So if you have an older version of Git, you would use git checkout, then the tag or the commit, and then 2 dashes to separate it from the file name. I would recommend just upgrading your Git if that's the case. Basically, the reason these commands change is because git checkout was used to switch branches and also to restore files from previous versions of your repository, and they split those into separate commands once they do separate things. So that's how you would get a single file. There's a slide missing here, so I'll just talk through it. Now, let's say I had, let's see what branch I'm on. I'm going to switch back to my master branch. let's say that I made these post-submission changes and I didn't like them. So what I can do is I can do git revert, which is going to create a new commit that undoes the changes in a different commit. So I can say I'm going to git revert 1140A3, which is my most recent commit. I'm going to run that. I'm going to say, okay, yes. It's going to prompt you what message do you want to put on this reversion. I just said I would keep the default message. You can also edit it. And so now those changes that I made are gone. And if we look at our log, so the idea with Git is you never want once you've committed something, it's forever. So it hasn't removed that commit. It's created a new commit after that commit that undoes that commit. And an important thing to remember is that this only reverts one commit at a time. So like if I wanted to revert this commit, this commit, this commit, and this commit, I would have to revert so that I could get back to how it was here. I would have to revert each one of these commits one at a time. So I wouldn't recommend reverting. Reverting is really good when you've committed something, you're like, actually, it's like the undo for when you realize that you've done something wrong. You can revert a commit or two. If you want to go back to an older version of your code, I would recommend doing what we showed a minute ago, where you check out a tag or a previous commit and then create a new branch based on that, and don't try to merge it back into your master branch. And in practice, you usually don't want to move your master branch backwards. But like, it's rare to have a project where you're like, actually, the way it was 2 years ago is actually, we want to throw away everything we've done in the last 2 years. Does that make sense? Any questions? People want to give folks a few minutes to try that out. Yeah. All right, seeing a thumbs up from Maddie. How's everyone else doing? All right. Anybody else? Any questions on that? Seems like, all right. So if you do have files in your repository that you don't want to commit, like if you're storing your data files in your repository, which a lot of times you might want to do, you can create a file in your repository that's called .gitignore. It has to be called exactly that and start with a period like that. And it can't have an extension like .txt or anything like that. And you can list files or file patterns you don't want to commit. So you could say like star.csv, I don't want to commit any CSV files anywhere in my repository. Or data, I don't want to commit my data directory, or a single file name, like I don't want to commit my API keys to the repository that I might make public at some point. So let's say I had another file in here that was called like super secret info. And I don't want to accidentally commit this file into my repository. And I also don't want to, every time I see git status and check to make sure I haven't made any changes, I don't want to see it keep listing that there's this untracked file there. So I could do new file here, and I can make a .gitignore. And in my gitignore, I'm going to list out that I don't want to commit super secret file. Save that. I spelled it wrong. And now you'll see that that super secret info file is no longer listed in my git status, and if I try to commit it, if I do git add super secret info, it's going to say it's ignored by your gitignore file. You can commit it if you really want to, but I think you don't. And you'll see in the git status now that it's saying that gitignore actually is one of my untracked files. And generally, you would want to commit your gitignore file to your repository so that if so that you can keep track of what you're ignoring. And particularly once you start doing collaboration, if other people have a copy of your Git repository, you want them to have the same Git ignore, especially if you're doing something where you've got like, so you've got a Python project and it creates a bunch of .pyc files that are just compiled versions of your Python code that you don't want to commit to your repository because they're just automatically generated, things like that. So you would ordinarily commit your Git ignore file. I think that's everything I have about Git on the, yeah, that's everything I have about using Git on your computer. I know we've like hit our time limit and I thought that might happen because Git's a very complicated piece of software. I'm happy to talk about GitHub now. I'd also be happy if we wanted to schedule a follow-on call to talk about GitHub separately from Git, just depending on what everybody's schedule and timeline looks like.
Unfortunately, I have another Zoom in about 15 minutes.
Me too. I have to run too. But this was really helpful. Thanks.
Great. Yeah, maybe we can set something up another time to kind of go through GitHub.
Yeah,
absolutely.
Great.
So yeah, since we are at Matt, like if Matt wants to stay on, if people have questions.
I'll stay on for a few minutes if people have questions.
Yeah, and also, I mean, Matt is really nice, so I'm sure that he would be open to answering some questions if you need to pass anything along via email later on.
Let me get to the end of here. I have some links as well to some other resources. So that there's a book about Git that's open access that's pretty good, especially if you get into more complex stuff. And then the GitHub help pages are pretty good as well. So
super helpful.
Yeah.
Yeah, so it's, Matt, can you send again, because I came in, I had to like log out and log back in. Can you paste again these 2 links in the chat so that I can include them with the video, the recording? Yeah. And if everyone like wants to unmute and just say a nice big thanks to Matt. This was really great and a great start to our workshop series.
Great. Yeah, thank you.
Thank you so much.
Thank you. Thank you, Matt.
All right, well, I hope everyone has a great rest of their day. And again, thank you so much, Matt, for your time.
Yeah.
Okay, bye everyone, thanks.
Bye guys, thank you.
Bye.
All right, well, Maddie, unless you had any questions, I guess we're done.
I don't at this point. I'm sure I will once I like use it a little bit more with my data.
Okay, all right, great.
All right, thanks. I have these links copied, and then I will save the recording to our like our drive folder, but then just send it out to the whole department. Is that are you okay with that?
Yeah, that's fine with that. I've got it. There's a few folks outside the department too who wanted to come and weren't able to, so I'll share it with them as well.
Awesome. Yeah, I'm trying to think if there's a better way, a place where we can eventually.
I mean, I'm fine if you want to just upload it to YouTube.
Them.
That doesn't bother me.
Oh, okay. Let me talk to Megan Martin to see there's like all of the media stuff, and if they already have like a kind of space where they are saving things, because it'd be great to like keep this.
Yeah.
Like upload it and keep it so everyone can like look at it years to come. So
great.
Let me talk to her.
All right, sounds good.
Okie dokie. Thanks so much. Bye.